Welcome to This Explainer. Look, if you work in infrastructure, you already know the pain. Bridging that massive gap between stateful data storage and dynamic, stateless containers, it's a huge headache. But today, we're demystifying Rook. We're going to break down exactly how Rook steps up as a cloud-native control plane, literally translating your declarative Kubernetes APIs into the heavy-duty orchestration needed to run Ceph storage natively inside your containers.
Let's jump right into the roadmap for this explainer. We're looking at Kubernetes storage meeting Ceph, Rook acting as your automated SRE, the reconciliation control loop, a handy CSI delivery service analogy, hardware discovery and networking, and finally some real-world production-grade YAML engineering. All right, Section 1. Kubernetes storage meets Ceph, classic versus masterless.
If you've ever banged your head against the wall deploying distributed storage, this comparison really highlights why. On one side, we've got classic file systems relying on centralized master metadata controllers. Basically, a setup just begging to hit memory limits and single-lock bottlenecks. Then, on the other side, we have Ceph. Ceph is the open-source gold standard for a reason. It uses a masterless design. Clients actually calculate data placement dynamically, completely sidestepping those centralized bottlenecks. But, here's the catch. Traditional deployment tools, things like Cephadmin, they just kind of fall apart in the dynamic, declarative world of Kubernetes.
And that perfectly tees up Section 2, Rook, your automated SRE and cloud-native control.
Okay, let's get one absolutely crucial point out of the way right from the start. Rook is not a storage engine itself. Seriously, let me repeat that. It does not store your data. Instead, think of this CNCF-graduated Kubernetes operator as a tireless, localized site reliability engineer. It takes your declarative custom resource definitions, your CRDs, and does all the heavy lifting, translating them into the really complex daemon orchestration you need to run Ceph. It's basically your personal storage automation bot.
Moving on to Section 3, the reconciliation control loop. Observe, analyze, act. So how does it actually work under the hood? Well, the engine of Rook relies on a continuous four-step loop. First up, it observes. It actively watches the Kubernetes API server for any tweaks to your CRDs, while also keeping an eye on nodes and disks. Second, it analyzes. It's constantly comparing the actual real-world state of your cluster against the desired state you declared in your YAML. Third, it acts. If a node goes down, it implements decisions like hitting the Ceph API to spin up new pods. And finally, it updates, tweaking the CRD status so you get crystal clear telemetry.
What's super interesting about this architecture is how that entire observe, analyze, act, and update loop physically sits right in the middle of everything. It acts as this perfect, seamless bridge between the Kubernetes control plane on one end and all those managed Ceph storage components and CSI drivers on the other. Honestly, it's the absolute brain of the whole operation.
Let's roll right into Section 4, the CSI delivery service analogy, comparing drivers and plugins.
Now, CSI often trips people up, so let's break it down with a really simple analogy. Imagine you're running a massive global e-commerce empire. The CSI driver, that's just the language or the protocol. It's the universal shipping standard telling the warehouse exactly how to label the boxes. But the CSI plugins? Those are your execution agents. They're the actual warehouse workers and the delivery trucks doing the physical, heavy lifting to make sure that shipping protocol actually gets fulfilled.
Continuing with that analogy, we can actually split those workers into two distinct groups. First, the provisioner plugin. Think of this as your back-office coordinator. It sits centrally as a Kubernetes deployment, and its job is to call the warehouse, meaning the Ceph APIs, to reserve space whenever a new order comes in. But it never actually touches the delivery trucks. The node plugin, on the other hand, is your on-site delivery driver. Running as a daemon set on literally every single worker node, it handles the local data plane. It's out there mapping devices, formatting them, and physically plugging that storage right into the customer's front door, which in our case is your application pods.
Now, depending on what your workloads actually need, Rook basically deploys two distinct drivers. The first is the RBD driver. This one is highly optimized for performance-heavy databases like PostgreSQL or MySQL that absolutely demand raw block storage. This gives you read-write-once access. The second is the CephFS driver. This is your go-to for shared file access and things like content management systems, giving you read-write-many access so multiple nodes can read and write all at the exact same time.
Which brings us to Section 5, hardware discovery and networking. Discover and isolate.
So how does Rook connect abstract compute nodes to physical bare metal drives? It deploys what's called the Rook Discover daemon set.
This privileged pod jumps into every node and scans the hardware bus using standard tools like UDEV and LSBLK. And you know what's really brilliant about this? It's incredibly safe. It automatically filters out active file systems and OS mounts so you don't accidentally nuke your own data, and then it safely writes all its findings into a local config map for the operator to parse.
Okay, so it found the hardware. Now it has to organize it. Back in the day, you'd be manually calculating physical racks and rows. A total nightmare. But Rook is smart. It simply reads native Kubernetes topology labels, things like zone, region, or even your custom rack labels, and uses them to automatically build a highly available crush hierarchy. This mathematically guarantees your data replicas are spread out across different failure domains, so if a localized power outage completely takes out a rack, your data is still totally safe.
And we certainly can't ignore networking. If you're running a high-throughput environment, Ceph's internal replication chatter can absolutely saturate your network. To fix this, Rook taps into Multis CNI. It essentially provisions your storage pods with multiple network interfaces, giving you true physical, wire-level segregation. This completely prevents Ceph's heavy internal replication traffic from starving out your actual client applications when they're trying to read or write.
All right, finally, let's get into Section 6, Production-Grade YAML Engineering, Production Configs. Let's bring all this theory back down to earth and look at the code. It all starts right in your Ceph cluster CRD. Check this out. By using a really strict device filter like this regex string right here, you're telling the Rook operator to only provision object storage daemons on dedicated NVMe drives. It just completely ignores everything else, meaning your OS partitions are kept totally out of the crossfire.
Once your cluster is up and healthy, you expose that storage using a storage class for your dynamic block volumes. But you don't stop there. You also define a volume snapshot class. This is an absolute game changer because it empowers your application developers to trigger instantaneous native copy-on-write snapshots straight through the Kubernetes API. No more submitting tickets to a storage admin.
And remember that critical network isolation with Multis CNI we talked about a minute ago? Implementing it is literally as simple as these few lines of YAML. You just instruct the Ceph cluster CRD to bind its daemons to the specific physical VLANs you've already set up. One for the public network, one for the cluster network, and boom, Rook handles the rest of the shebang. And lastly, what about external systems that need to completely bypass standard persistent volume claims, like, say, an external backup system? The Ceph client CRD has you covered. It lets you automatically generate cryptographically secure keyrings. You can lock things down with strict, least privilege access restricted to very specific pools. And Rook just handles generating those keys natively as standard Kubernetes secrets. So, we've seen how Rook takes Ceph and turns it into this fully declarative, self-healing fabric that just hums along seamlessly under Kubernetes. It totally rips out the need for archaic CLI scripts and messy SSH tunnels, which really leaves us with a pretty provocative question to end on. With Kubernetes operators stepping in as these tireless, automated, localized SREs, are we actually looking at the end of the traditional storage administrator? Definitely something to chew on. Thanks so much for joining me on this explainer, and as always, keep learning.